Hi, this is my fourth devlog, and in my first video, I ended by saying I needed to improve wire routing to make logic circuits less messy, and I finally figured out how I wanted to improve that system, so that's what I worked on this month. I started by adding the ability to rotate gates. This was not in the original system because my wire routing algorithm assumed all gates were at the same orientation, which made things a lot easier. This gave me 3 wire types, which were all relatively easy to draw. My new system needs 6 and a whole lot of vector math. Luckily, while I do need to map 2 buttons to rotate gates, drawing wires is still just dragging between gates, so things are still very simple for the players. To build these 6 routing algorithms, I created 6 separate scripts, each of which just calculated the turning points of each wire type and showed those positions with spheres. After I got each of those running, I copied the routing functions into a 7th script, which switched between the 6 algorithms based on which was needed to connect the gates. Finally, I copied all that into the actual logic mesh script where I implemented the actual wire orientation calculations and vertex placements. Making everything modular made it much easier to hunt down bugs, but this is by far the most I've ever encountered the code works, copy it to another script, now it does something different problem. And it got very frustrating. It was still worth separating everything out, it's just less helpful than I had hoped. I won't go over how each of the wire calculations works. It took me 3 weeks to build, so it would take at least 20 minutes to run through. The end result is that the gates are a little more intuitively placed since they don't all have to be at the same orientation, but the real benefit of rebuilding everything is that wires now work at any orientation. Every gate is now set to a work plane, which I did have to add to the circuit save file, so gates can be placed on floors, walls, random objects, and as long as none of the surfaces move relative to each other, I can place gates anywhere without having to create a separate logic manager. Switching work planes is not something the player will be able to do in-game, though. They can only edit gates on the work plane they're standing on. This limitation prevents the player from reaching faraway gates to break puzzles, and more importantly, prevents them from trying to draw wires between work planes. This is important because there's currently no auto-routing system for drawing wires that switch planes. I only have a manual one, which was difficult enough to make that it led to me giving up on fixing the wire system until now. I have found a solution, but let me explain the problem first. If you take this set of points, you can connect them with a wire like this, but this also works, and this. These are all viable solutions unless I narrow it down with some algorithm checking the ground at every turn, which would be complicated and inefficient. To nail down this one as the proper way to draw the wire, I would have to record the normal vector of the wire at every point. This is not only less efficient, but makes drawing a wire when building levels much more difficult as I have to draw that vector for every point. And sadly, if you want to be able to draw a wire segment between any 2 points, this extra information is necessary. I realized this a while ago, but still wanted to find a way to draw wires with just a set of points, and luckily for me, this wire route is very ugly. Something nicer might look like this. Here, every time the wire switches planes, it hits the corner at a 90-degree angle. This is a stylistic choice, but if I make it a hard rule of drawing wires, it's now possible to calculate the normal vector of every wire segment using only the points. But only if you start at one of the gates and know its normal vector, which we do. Before I run through that process, I need to mention what a cross product is. The cross product of 2 3-dimensional vectors is a vector that's 90 degrees from both of the input vectors and has a length proportional to the angle between the 2 vectors and the length of both input vectors. Here's the math if it means anything to you. Looking at the first point off the gate, the cross product of the direction the wire enters and leaves that corner looks like this. If that vector is very close to the gate's normal vector, this wire segment and the last are on the same plane, so we draw the wire corner on that plane. To find the actual location of the vertices that make up this corner, we normalize both vectors before adding them together. This gives us the average vector. Then we take the cross product of that and the normal vector to get the vertex offset. And this corner is now drawn. After we record that, this corner inherits the gate's normal vector since they share a plane, and we move on to the next point. Looking at the next point, the cross product looks like this. Since it's not in the same direction as the last point's normal vector, we know this is a corner between 2 different work planes. Since these turns have to be made at 90-degree angles, the vertices for the wire are just the turning point plus and minus the cross product. Since we switched work planes, we need a new normal vector, which can be calculated as the cross product of the cross product we already have, and the vector from this corner to the next corner. Now we just continue this process all the way down the wire, propagating the normal vector along to be used for every point until we have the entire wire drawn. The only problem is that the wire occasionally flips upside down like this. I spent most of today trying to fix this, and after 5 hours finally gave up on trying to predict which way the vertices need to flip and just threw them down and checked if the first vertex of this corner and the first vertex of the last were on opposite sides of the wire, and swapped the two vertices that made up the corner if they were. An obvious solution, hidden by the fact that I knew there had to be a solution that didn't involve checking my outputs. Not the most efficient use of a month, but with this, the logic circuit display system is now fully functional. It could be more elegant, but aside from any bugs I may encounter, I finally have a sizable piece of my game that could remain unchanged until release. I currently just have bug fixes and an ongoing physics overhaul scheduled for next month, so next video will likely be about whatever I work on in the last week of August. Anyway, thanks for watching. Bye.